The Global Positioning System, commonly known as GPS, has become an essential part of our daily lives. From navigating through unfamiliar cities to tracking packages and even enabling emergency services to find those in need, GPS technology is woven into the fabric of modern society. But how did this remarkable system come to be? And how does it actually work? To understand the story of GPS, we need to travel back several decades. The origins of GPS are closely tied to the Cold War era, a time when the United States and the Soviet Union were locked in a technological race. In 1957, the Soviet Union launched Sputnik, the world's first artificial satellite. This event shocked the world and inspired a wave of innovation in the United States. Scientists noticed that as Sputnik orbited the Earth, its radio signal would change in frequency due to the Doppler effect. By analyzing these changes, they realized it was possible to determine the satellite's position. This insight laid the groundwork for satellite-based navigation. In the years that followed, the United States military began developing systems that could use satellites for navigation. The first of these was called Transit, deployed in the 1960s for the Navy's submarine fleet. Transit allowed submarines to determine their position with greater accuracy than ever before, but it had limitations. It was slow and could only provide updates every few hours. Recognizing the need for a more advanced system, the U.S. Department of Defense set out to create a global navigation system that would be fast, accurate, and available anywhere on Earth. This ambitious project became known as the Navstar Global Positioning System, or GPS for short. The first experimental GPS satellite was launched in 1978, and over the next 2 decades, the system was gradually expanded and improved. But who can be credited as the inventor of GPS? While many brilliant minds contributed to its development, one name stands out: Dr. Ivan Getting. As an engineer and physicist, Dr. Getting played a pivotal role in conceptualizing and advocating for a satellite-based navigation system. He worked alongside other key figures, such as Dr. Bradford Parkinson, who is often called the father of GPS, due to his leadership in designing and deploying the system. Ultimately, GPS is the result of decades of teamwork, innovation, and collaboration among scientists, engineers, and government agencies. So, how does GPS actually work? At its core, GPS is a constellation of satellites orbiting the Earth. There are at least 24 operational satellites in the system at any given time, spread out so that at least 4 are visible from any point on the planet. Each satellite circles the Earth twice a day, transmitting continuous signals that contain the satellite's location and the precise time the signal was sent. On the ground, GPS receivers, like those in smartphones, cars, or handheld devices, listen for these signals. The receiver's job is to determine how long it took each signal to travel from the satellite to the receiver. Because radio waves travel at the speed of light, the receiver can calculate the distance to each satellite using the time delay. But knowing the distance to just one satellite isn't enough. The magic of GPS comes from a process called trilateration. Imagine you know you are 20,000 kilometers from satellite A. That means you are somewhere on a sphere. With a radius of 20,000 kilometers, Mayu's centered on satellite A. Now, if you also know you are 21,000 kilometers from satellite B, you are somewhere on the circle where those 2 spheres intersect. Add a third satellite, and your position narrows down to 2 possible points. Usually, one of these points is not on the Earth's surface, so it can be discarded. With a 4th satellite, the system can also correct for any errors in the receiver's clock, providing an accurate position in 3 dimensions: latitude, longitude, and altitude. Timing is everything in GPS. The satellites carry extremely precise atomic clocks, accurate to within billionths of a second. Even a tiny error in timing can result in a large error in position. For example, if the timing is off by just 1 microsecond, the calculated position could be wrong by about 300 meters. To ensure accuracy, the GPS system includes ground stations that constantly monitor the satellites, updating their positions and time data as needed. One of the most remarkable aspects of GPS is its global accessibility. Originally developed for military use, GPS was made available for civilian applications in the 1980s. In 2000, a significant milestone occurred when the U.S. government removed selective availability, a feature that intentionally degraded civilian GPS accuracy for security reasons. This decision unlocked the full potential of GPS for everyday users, enabling precise navigation for everything from aviation and maritime travel to hiking and driving. Today, GPS is not the only satellite navigation system in the world. Other countries have developed their own systems, such as Russia's GLONASS, the European Union's Galileo, and China's Beidou. However, GPS remains the most widely used and recognized. The impact of GPS on society cannot be overstated. It has revolutionized transportation, enabling real-time navigation and logistics. It supports scientific research, from tracking wildlife migrations to monitoring earthquakes. GPS also underpins critical infrastructure, including telecommunications networks, financial systems, and power grids, all of which rely on precise timing. As technology evolves, GPS continues to improve. Newer satellites offer enhanced accuracy, better resistance to interference, and greater resilience against cyber threats. Researchers are exploring ways to integrate GPS with other sensors and systems, paving the way for even more reliable and precise positioning in the future. In summary, GPS is a marvel of human ingenuity, a system born from the challenges of the Cold War, brought to life through decades of collaboration, and now an indispensable tool for billions of people around the world. Its invention is a testament to the power of science and innovation, and its operation is a fascinating blend of physics, engineering, and mathematics. The next time you use your phone to find your way, remember the remarkable journey that made it possible.